solve system linear equations using matrix method. So first of all, you write the system linear equations in matrix form. So the quotient matrix will be C1, 3, 2, minus 1, 4, minus 1, and the coefficients of Z are 2, minus 5 and 3. We are just collecting the coefficients of X, Y, Z in the columns. And then the variable matrix and column as a column matrix X, Y, Z and equal to the constants 7, minus 5, 12. And now if I denote the quotient matrix by A, keeping the variable matrix and the constant matrix as such, it may be written like this. Multiplying both sides by A inverse, we get X, Y, Z, the variable matrix, equal to A inverse. Remember, you have to multiply, pre-multiply, that is on the left of the constant matrix, that is a must. So 7, A inverse times 7 minus 5, 12. And now it is just a matter of, call it 1, finding A inverse and replacing the value in 1. To find A inverse, you need determinant A and adjoint A. By the way, what is the quotient matrix? It is 1, minus 1, 2, 3, 4, minus 5, and 2, minus 1, 3. So let us first of all work out the value of determinant A, and we'll expand along R1. So you get 1 time, delete the row and column through 1. You know the sign convention, plus, minus, plus. So it will be plus 1 time, delete the row and column, and you get 12 minus 5. Then minus, but it is already minus, so minus, minus, plus 1 time, delete the row and column through minus 1. You get 3, 3, 9, and minus, minus, plus 10. And then plus 2 times, delete the row and column through 2. You get minus 2 and minus 3, sorry, minus 3, minus 8. Work it out, you get, see, the value of determinant A equal to 7 plus, it was, just wait, minus, 339, please make a correction, it is plus 9 here. So 7 plus 19 and minus 22. So you work out, you get 4. So finally the value of determinant A is 4. And now let us work out the value of adjoint A. What is adjoint A? It is the transpose of a matrix obtained by replacing each element by the corresponding cofactor, that is C11, C12, C13, C21, C22, C23, C31, C32, C33. And how do you work out the cofactors? Delete the row and column through that element, work out the value of the remaining determinant, and with a proper sign, that is minor with a proper sign, and the proper signs are assigned like this: minus, plus, minus, minus, plus, minus, plus, minus, plus. So now using all this, let us work out adjoint A, and don't forget it is transpose of the cofactor matrix. For C11, it will be plus time, delete the row and column through 1, you get 12 minus 5, plus outside 12 minus 5. And minus times, delete the row and column through minus 1, you get 9 minus minus plus 10. And then plus times, it is delete the row and column through 2, you get minus 3 and minus 8. Minus 3 and minus 8. Similarly, you work out for second and third row, you will get negative times, negative 3 plus 2, and plus times 3 minus 4, and minus times minus 1 plus 2. Likewise, for the third row, it is plus times 5 minus 8, minus times minus 5 minus 6, plus times 4 plus 3. Just work it out and you get transpose of, don't forget the transpose, 7 minus 19 minus 11, 1 minus 1 minus 1 minus 3, 11, 7. Now finally you get adjoint A as transpose of it. So elements of the first row, that is 7 minus 19 minus 11, we write in the first column. That of the second row, 1 minus 1 minus 1 in the second column, and third row minus 3, 11 and 7 in the third column. And we have already worked out the value of determinant A equal to 4. So the value of A inverse is 1 by determinant A into adjoint A. That is 1 by 4 times. You already know adjoint A, 7, 1, negative 3, negative 19, negative 1, 11, negative 11, negative 1, 7. And now replace this value in 1. And hence from 1 you get XYZ equal to A inverse. That is 1 by 4 times 7, 1, negative 3, negative 19, negative 1, 11 and negative 11, negative 1, 7 times the constant matrix, which happens to be 7 minus 5, 12. And now it is just a matter of multiplication. This is from 1. So you get 1 by 4 times, multiply row to column. So you get 49 minus 5 minus 36. Repeat the process with the second row and you get minus 133 and minus plus 5 and plus 132. And then repeat the same with the third column. You get minus 77 and plus 5 plus 84. Just work it out. It is 1 by 4 times, if you add the elements in all the 3 rows, you get 8, 4, 12. So you get finally on the left XYZ, the column variable matrix, equal to 1 by 4 times 8, 4, 12. Multiplying each element by 1 by 4, you get 2, 1, 3. So now equating the respective elements, because both the matrices on both the sides are of the same order, you get x is equal to 2, y equal to 1, and z equal to 3. That is the required solution.